TCP-IP model. Now, if you remember all the way back out when I started talking about the OSI model, we mentioned that the OSI model was a reference model, but it wasn't the only reference model out there. And the other one that we're going to talk about is known as the TCP-IP model. This is also called the TCP-IP stack or the DoD model, named for the Department of Defense, who created it. Now, the TCP-IP model is an alternative to the OSI model, and the nice thing is it's actually only 4 layers instead of the 7 layers of our OSI model. This is going to make it a little bit easier for most people to understand, and it's also easier for us to learn this model. Now, it's also going to be a little bit more relevant than the OSI model today, because almost all computer networks these days are TCP/IP based, and the TCP/IP model refers specifically to those 4 layers and how things work in today's modern networks, whereas the OSI model is going to sometimes be a little bit more blurry as you're trying to force things into those 7 individual layers. So, how does the OSI model compare to the TCP/IP model? Well, I already mentioned that there's 4 layers in one and 7 in the other. Let's take a look at that. So how exactly does the OSI model compare to the TCP/IP model? Well, it's actually pretty simple. If I take layers 5, 6, and 7 from the OSI model, those top 3 layers, and I smash them all together, I get something known as the application layer inside the TCP/IP model. Now, the application layer here is going to contain application, presentation, and session, all of those OSI model functions, into a single layer called the application layer under the TCP/IP model. Next, we have the transport layer from the OSI model, and this one is really easy because we're just going to take it and move it right in to the TCP/IP model. Everything the way that it was in the OSI model still applies here. Next, we get down to the network layer of the OSI model. Here, we're going to take this layer and move it straight over to the TCP/IP model as well. But when we do that, we're going to change its name. Instead of calling it the network layer under the OSI model, we're going to call it the internet layer inside the TCP/IP model, because it really is all about routing things externally, either to or from the internet, from within our networks. Then we have our final 2 layers at the bottom of the OSI model. This is our data link and our physical layers. These 2 layers are going to be combined under the TCP/IP model and called the network interface layer, because this is how our users are going to interface with our networks and connect to them. So as you can see, this is pretty simple when you start looking at the OSI model versus the TCP/IP model in this way. You basically take the top 3 layers and you squish them all together, and this gives you the application layer. You take those bottom 2 layers and you squish those together and you move them over into the TCP/IP model. And that's how you go from 7 layers of the OSI model into the 4 layers of the TCP/IP model, by making sure you squish those top 3 and squish those bottom 2 layers together. Now, for the exam, you need to understand the TCP/IP model and its layers. So if you can draw this diagram, you're going to be covered because you already know everything else you're going to need for the test. See, what we're dealing with here is knowing what those 7 layers are of the OSI model and how they represent themselves inside the 4 layers of the TCP/IP model. We already learned all about those 7 layers individually in the OSI model, so that knowledge is going to carry over too. Now, let's take a quick look at these 4 layers in the TCP/IP model as a review from our days using the OSI model. First, starting at the bottom, we have the network interface layer. This is layer 1, and it's all about physical and electrical characteristics, just like in the OSI model. Now here we're going to describe how we're going to transmit bits across our networks, those 1s and 0s that we had in our physical layer. It's also going to determine which type of network medium we're going to use. Are we going to be using twisted pair copper cabling, coaxial cable, fiber optic cable? What do we want to use here? Maybe we're going to use wireless. Are we going to run TCP over Ethernet, or are we going to use token ring, serial, or some other type of network? All this gets put together inside our network interface layer. The second layer we have is known as the internet layer inside the TCP/IP model. This is where we take data and package it into those IP datagrams, just like we did with layer 3 of the OSI model before. Now, it's going to contain your source and your destination IPs, and it's going to forward those datagrams between different hosts across the networks. These datagrams are going to be pushed around the networks through routing, and we're going to use our routers to do this. And this connectivity is usually going to occur externally from your network to some remote network. This is where your intranet is going to get connected to the internet. This is internal versus external. Now, examples of the internet layer in TCP/IP include things like IP, ICMP, ARP, and reverse ARP. And we're going to talk all about these things in more depth as we go through switching and routing later on in this course. Now, I understand I just threw a bunch of acronyms at you, but I promise I'm going to come back to them later and I'm going to teach you all about them, so don't worry about them yet. Next, we have our third layer. This is the transport layer, and it's exactly the same as the transport layer in the OSI model. It's going to define the level of service and the status of the connection being used by TCP, UDP, or RTP. TCP is our connection full protocol, UDP is our connection less protocol, and RTP is our real-time protocol, which is normally used for streaming voice and video. The fourth and final layer of the TCP/IP model is the application layer, and it's going to combine the top 3 layers of the OSI model into a single layer to define the application protocol that we're going to be using. This is also going to dictate how the programs are going to interface with the transport layer by conducting session management, and it's going to be the layer where the user is going to interact with the network through some sort of program. Examples of this come from layers 5, 6, and 7 of the OSI model, again because we squished all 3 of those down into this one application layer. This would be things like the Hypertext Transfer Protocol for web browsing, Telnet for remote control, FTP for file transfer, SSH for remote shell, SNMP for network management, DNS for domain name resolution, SMTP for sending mail, and SSL or TLS for secure web browsing and encryption. All of these things are going to be found here in the application layer of the TCP/IP model. All right, so what are we going to cover in this section of the course? Well, we're going to be focused again on Domain 1, Networking Fundamentals, and we're going to cover Objectives 1.1 and 1.5. Objective 1.1 says that you must be able to compare and contrast the OSI model layers and encapsulation concepts. Objective 1.5 states that you must be able to explain common ports and protocols, their applications, and encrypted alternatives. We're also going to briefly dive into Domain 5, Network Troubleshooting, by returning to Objective 5.3. Objective 5.3 states that given a scenario, you need to use the appropriate network software tools and commands. So in this section, we're specifically going to be doing some hands-on work with Nmap, the network mapper tool, to show you how this works. All right, let's get started talking all about ports and protocols using the TCP/IP model in this section of the course.